Hello and welcome to our final video on Introduction to Thunderstorms. In this video we're going to talk about visual features. So visual features are things that you can see in a thunderstorm, things that tell you something about a thunderstorm. And we'll start out with this diagram that was drawn by Chuck Doswell, who's a well-known research scientist and storm chaser who worked at the Severe Storms Lab and also the Storm Prediction Center for a number of years. So what this is a supercell, and it shows you all the key features on a supercell thunderstorm. You may find this with other storms, perhaps each feature, but they're not totally exclusive to supercells. So we'll start out with the top of the storm, and we'll look at the anvil. And the anvil of a thunderstorm is the region of the thunderstorm where the air is coming out of the top and then spreading out. And typically the strong jet stream winds blow the cloud downwind. So here you can see a thunderstorm well in the distance, and the anvil's going all sorts of different directions. Here's one from altitude. This one was taken over West Texas during the weather modification project. And it shows the back sheared anvil. In other words, the part of the anvil that's going against the upper level winds. Usually when you have a back sheared anvil, it tells you that the thunderstorm is pretty strong. And here is an anvil that's just forming in a thunderstorm over western North Dakota. And a really nice picture with the sun in the background. Mammatus clouds form in the anvil, and the result of precipitation falling out of the storm into the anvil. As it falls through the anvil, the precipitation evaporates at high altitude and produces these really beautiful looking clouds. Typically Mammatus are regions where there could be turbulence as a result of the evaporation. The evaporation causes downdrafts, and there's a lot of little localized downdrafts in the Mammatus. Typically altitudes Mammatus vary with the height of the anvil. But during the summertime, you'll find bases of Mammatus at about 20,000 feet or so. This picture was taken by a friend who flew weather modification. This is over western Oklahoma, and you can see this anvil taken from a Cessna 340. Mammatus is probably bases here about maybe 25,000 feet. But this is out ahead of a squall line of a thunderstorm, and you can see out in the distance the beautiful anvils from other storms. Overshooting tops of a thunderstorm are the indication that the thunderstorm has a very strong and vigorous updraft. So the thunderstorm is punching through the tropopause into the stratosphere, and that's what overshooting tops are, the burbling part that's going up into the stratosphere. Pileus or Pileus clouds are little thin wispy clouds that form on top of growing towering cumulus clouds, usually an indication of a very vigorous updraft. It's pushing the air up above the updraft and allowing it to spill around the sides. After a period of time, after the cumulus is growing, it'll punch through the Pileus clouds and just produce kind of wispy clouds around the Q. The flanking line is found on the back side of supercell thunderstorms. Usually it looks like an area of growing cumulus clouds, but because with supercells you have downdrafts on the back side of the storm, this region never really fully develops. It looks kind of menacing, but it really doesn't develop into much. The precipitation shaft indicates that the storm has reached its mature stage, and you'll find precipitation in various locations around a thunderstorm, depending upon the type of storm. Here's a picture in Florida of precipitation falling out of a thunderstorm, and you can see that as the precipitation falls, it's reaching the ground. That's not always the case. Sometimes the precipitation evaporates before it reaches the ground, and we call that virga. That depends upon the height of the cloud base and also the amount of moisture in the lower layers of the atmosphere. A wall cloud is an indication that the thunderstorm has a rotating updraft, and the wall cloud is the lowering portion of that rotating updraft. Usually this is where you look for the tornado development. And here's a well-developed rotating wall cloud showing it's reaching the ground and soon to produce a tornado. Here's a picture of a tornado underneath the thunderstorm. This is occurring in western North Dakota near Minot on a weather modification project back in the 1970s. And then, of course, the gust front is the manifestation of the cold air flowing out of the thunderstorm. Sometimes it can be visible by the dust that it kicks up and also the moisture that it contains. So in this Florida thunderstorm, you can see the leading edge of the nose of the gust front. Here's another picture from altitude. This is over Montana and western North Dakota, looking at the air flowing out of a thunderstorm. And then, as I mentioned, dust kicked up by the gust front in areas where it's arid makes it visible. And then the shelf cloud may either look turbulent or smooth. This one is over western North Dakota. Actually, this is over Bismarck. And it shows the warm, moist air flowing into a thunderstorm. This one looks a little bit more turbulent. This one was taken over central Oklahoma back in the 1980s. And it shows the lowering as a result of the warm, moist air flowing into the thunderstorm. And it looks like there's a little bit more turbulence associated with this one. And then here's a picture of a shelf cloud taken by NOAA. Those are all the visual features of thunderstorms. I hope you enjoyed this presentation.